Solving a word problem involving geometry using a system of nonlinear equations. The perimeter of a rectangle is 35 and 6/10 centimeters, and its diagonal length is 13 centimeters. Find its length and width. First thing you want to do is draw a picture. Let's draw a rectangle. And in that rectangle, there is a diagonal. Let's say that diagonal goes across that way. And the length of that is 13 centimeters. In a rectangle, there is a right triangle here, or a right angle here, that forms a right triangle. So we could take a good look at this triangle right here. Let's call this the width, and let's call this the length. So there are a couple of relationships going on. One, we know the entire perimeter of the rectangle. The entire perimeter is this outside. And we know that's given. P is equal to twice the length plus twice the width. And we know that the perimeter is 35 and 6/10. We also know a relationship using the Pythagorean theorem for right triangles. We know that the square of the legs, adding them up together, so L squared plus W squared, is equal to 13 squared. We're going to take, let's say, an equation over here on the left, and we're going to apply a substitution. So why don't we solve for W? If we solve for W, we're going to get 35 and 6/10 minus 2L, and we're going to divide this by 2. What is W? Let's see. What's 35 divided by, 35.6 divided by 2? 17.8. And now we have minus L. I'm going to take that W and substitute it over here. We get L squared plus 17.8 minus L quantity squared is equal to 13 squared. Let's simplify this. L squared plus, I'm going to multiply 17.8 times 17.8, and we get 316.84. Going to minus here 35.6 times L, and then finally plus an L squared is equal to 169. Let's simplify this. 2L squared minus 35.6 times L plus 316.84 minus 169, set that equal to 0. Let's see what we have here. 2L squared minus 35.6 times L, and let's see what that simplifies to. 316.84 minus 169, and we get plus 147.84 is equal to 0. Let's factor out a 2, and we get L squared minus back to 17.8 times L, and then let's say 147.84 divided by 2. That is 73.92 is equal to 0. Now we're going to go ahead and apply the quadratic formula to this part of the equation. And remember, what is the quadratic formula? L is equal to the opposite of B plus or minus this part of the equation, plus or minus the square root b squared minus 4ac divided by 2a. Let's go ahead and substitute. L is equal to the opposite of b, so 17.8 plus or minus the square root of b squared, and that is 316.84 minus 4 times 1, which is 4, and then c, which is 73.92, all divided by 2 times a, which is 2 times 1. Let's do a little bit of calculator work. Simplifying this on a calculator, we do, let's say, 4 times 73.92, and I need the negative answer of that. Add that to 316.84, take the square root of it, okay, and so we get L is equal to 17.8 plus or minus 4.6, all divided by 2. Let's see what happens here. So we either get L is equal to 17.8 plus 4.6, okay, divided by 2, which is 11.2 centimeters, or L is equal to, let's see what the other number is. You should get 6.6. So what happens when L is 11.2? When L is 11.2, we need to find W. How can we find W? Let's go back and look right here where that green star is, or where that star is. And let's find W. W is 35 6/10 minus 2 times, let's say, 11.2, all divided by 2. Let's figure what that is. 35.6 minus 2 times 11.2 into your calculator, divided by 2. And not a total surprise, we get W to be 6.6. So these two are matching up together. And really you're done, because if the length is 6.6 centimeters, then what would have to be the width? I'm pretty sure you could figure that part out. If the length is 6.6 centimeters, then we simply call the width to be 11.2 centimeters. So really, just finding one of these rectangles is enough. So we could say the length is 11.2 centimeters and the width is 6.6 centimeters.